Okay, so today's lesson is focusing on, at first here, just on the words that are used in our math problems. And I think it's a lesson that would be easy to skip over and not take very seriously, but in many ways, this is actually one of the most important lessons that you'll be using all year long in school. A lot of the problem on standardized tests is just not understanding what the question's asking for. So that's a lot of what this is focusing on, is just recognizing the words that are used to say whenever you're supposed to multiply or whenever you're supposed to divide, or et cetera. Okay, so you can see this table here at the top. So this is gives us examples of the words. So you can see, like, for addition, the words that you'll use would be like sum, plus, total, more than, increase by. So the way they would be used in a sentence would be things like the sum of 2 and a number x and a number n plus 7. For subtraction, the words that you'll see difference is probably the most common one that you'll see, less than, minus, and decrease by. So used in a sentence, that would be like the difference of a number n and 6, so n minus 6, and a number y minus 5, so y minus 5. Then we have multiplication, which is times, product, multiplied by, and of, which I'm always a little uncomfortable with because you could use that in a sentence to signify other operations, but more times than not, it will mean of. So like 12 times the number y, that would be 12y. 1/3 of the number x, that's 1/3 x. And then division, the words quotient, divided by, divided into. So not as many there. So we have, like, the example, the quotient of a number k and 2, so that would just be k divided by 2. Now, the other important part of this is just keeping the order straight in what you're reading and making sure that you line everything up whenever you're writing out your problem. So you can see in the example here, we have 4 less than the quantity of 6 times the number n. Okay, so the first, you kind of want to look at the last part here. So it's 6 times the number n, so that's just 6n. And we want 4 less than the quantity. So it doesn't say 4 minus that, it says 4 less than the quantity of 6 times the number n, so 6n minus 4. So again, so be careful on the wording, make sure that you understand what they're asking for. Okay, for B, it's 3 times the sum of 7 and a number y. Okay, so again, it's not 3 times 7 and it's not 3 times y, it's 3 times the sum of 7 and y. You remember sum up here, that means addition. So we have 3 times 7 plus y. Okay, and then for example C, we have the difference of 22 and the square of a number m. Okay, so you remember difference, that means subtraction up here. And we have 22 and the square of a number n, so minus m squared. Okay, for this one, this is just writing an expression from a word problem. So it says a piece of ribbon L, feet long, is cut from a ribbon 8 feet long. Write an expression for the length in feet of the remaining piece. Okay, so we're starting off with 8, and we are subtracting the 2 feet, or I'm sorry, the L feet. I'm looking too far down to the example. Okay, so like if we were taking 2, it would be 8 minus 2, right? So that would be 6. So, okay, so this would just be 8 minus L. So that's what's going to end up being our expression here. Okay, and this next part is using a verbal model. A verbal model, you're just taking a real-world situation and you're using words as labels and using the math symbols to relate the words. So in our example down here, we have example 3. So you work with 5 other people at an ice cream stand. All the workers put their tips into a jar and share the amount in the jar equally at the end of the day. Write an expression for each person's share in dollars of the tips. Okay, so again, if you're writing your verbal model, you have the amount in the jar, so that was A. And then you have the number of people who are splitting that. So it said you work with 5 other people, so it's not just 5, it's you and the 5, so there are 6 people. So if we're putting this in here, that would just be A divided by 6, and that will give you the share for each person. Okay, for this next one, we're talking about rates. So rate is just a fraction that's comparing 2 quantities measured in different units. Okay, and these, I don't know, these kind of remind me of, let me scoot this down a little bit and give myself some space up here. These kind of remind me of like whenever you have a problem that you need to reduce and you have, say, 3/5 times 10/, let's do 21. Okay, so whenever you need to go in and reduce this, you're just looking for common factors that you can take out. So like you can do the 3 and turn that into a 1, and you do the 21 and turn that into a 7 because you're factoring out the 3. And the same thing here, you have the 10 that you can change to a 2 and that 5 to a 1. So you multiply across and you just have 2/7. Okay, so these problems are actually very similar, except even besides factoring out the numbers, you can actually go in and factor out the words too. So you'll see what I mean here. Okay, so for our example here, it says a car travels 120 miles in 2 hours, and we're going to find the unit rate in feet per second. I don't want to just show it here, so I'm going to set it up on the next screen so we can work this one out. Okay, so we have our 120 miles in 2 hours. We want to get this into feet per second. So we're going to keep setting these up until we end up with feet per second. Okay, so we need to get equivalent measurements here. So, for example, we have our miles up here, and we can say that 1 mile is equal to 5,280 feet. Okay, so we have our feet. Now we need to get to seconds. Okay, so we have 1 hour and 60 minutes and 1 minute and 60 seconds. Okay, so now we can go in and start canceling, and like I said, you can actually cancel out the words here. So let's do that first, okay? So we can cross out miles. Let's see here, what else do we have top and bottom here? We have minutes. And we have hours. Okay, and I think, yeah, now we are left with our feet per second. Okay, and let's do the same thing here with the numbers. Okay, so like you have a 60 here and a 120 up here, so we can change that into a 2. And I'm trying to see, do we have any? Okay, yeah, we can just cross out our 2 and 2. Okay, and so now we are left with 5,280 up top, and we have 60 on the bottom. I'm going to go ahead and save everybody the math and tell you that is 88. And then we have feet left up top and seconds on the bottom, so that's just feet per second. So our answer is 88 feet per second.